Hi everyone. Let's talk about air conditioning. And let's talk about air conditioning in your home to understand the basic principles of this. I'm going to use my home as an example. I live here in Iowa. And so today I'm in cooling mode, meaning it's hot outside and I want air conditioning. And I want it to be 75 degrees inside my house. And it is 92 degrees outside. So that's a change in temperature of 17 degrees. Now, my system at home, I have what's called an indoor furnace with an A coil and then an outdoor condensing unit. And then I have a refrigerant loop in between. So I have my indoor fan that's gonna blow air across an A coil. And we call it an A coil because it looks like an upside down V. So there's refrigerant going through each side of this V. And air goes across the V just to have the most surface area that's touching. But let's focus on this refrigerant. So the refrigerant is going to go through this coil and then in a loop that's going to go outside to my condensing unit. So we need to remember heat goes from hot to cold. So I'm inside my house, I'm returning 75-degree air and I want to see off that coil more like 60-degree air. So I want a 15-degree change in temperature that I want to reject heat into the coil, into that refrigerant. So I need to have cold refrigerant coming to me. So cold refrigerant comes in, goes through the A coil and heats up. It absorbs the energy out of my air and it goes back out to the condensing unit. And you might think, well, it's hot outside. How are you going to reject the heat? The condensing unit condenses that refrigerant. And when you condense something, you actually make it, all the atoms inside move around, get excited more and more and more, and they generate heat. And so now this refrigerant fluid is hot. It's very hot, 110, 115 degrees. And so it's quite a bit warmer than the outside temperature. So when it goes through the coil that's outside and there's a fan blowing across it just to induct air across that, I'm able to transfer the heat from my refrigerant coil outside to the ambient air. And then once it goes through that coil, there's an expansion valve that I say, hey, you can expand refrigerant and it rapidly cools down because I've rejected heat and now I've given it more space, more volume to expand in, and it can go back to my indoor coil cold. And we just keep doing this again and again and again all the time because I'm in Iowa. So if you have any other questions, reach out to me. Otherwise, this is the building blocks that we're going to talk about for heat pumps and VRF systems very soon. Thanks.